rocket on its launch pad. The launch service tower has just been retracted, as Guido just told us, and we can see the rocket there standing in a tube. Now, can you explain what that is?
Yeah, that is actually a very particular feature of the Rockot launch vehicle. To understand this, one has to know that the Rockot launch vehicle is actually derived from an intercontinental ballistic missile, the SS-19. And we have seen earlier in the video when the upper composite was lifted into the tower that there was already a part standing inside the launch tower, and that is actually the part that is inherited from the SS-19. So the SS-19 as a weapon system was constructed in such a way that it could be launched out of a container in which it could be transported basically anywhere, and for strategic reasons then launched out of that container. So the Rockot is basically adapting this launch mechanism in order to change the design of these two stages, and we basically put on top the upper stage that carries the satellite, and that makes the Rockot. That's why we see the launch vehicle only sitting in the container, and the first time that we actually see Rockot completely is when it lifts off out of the container.
Let's have a little look quickly at the clock and see where we're at now. Just under 3 minutes to go. Now, if we look at that Rockot, you said already that it was a small rocket, but how large actually is it?
It's almost 30 meters high, a bit more than 29 meters, and it weighs 107 tons. So, yeah, that is small for a launch vehicle, but still quite impressive when you stand next to it at the
Yes,
pad.
I'm sure. Now, we are, of course, in the crucial few minutes, but over the last few hours, there's been a lot of activities going on. Can you talk us through what's been happening?
You just showed the countdown, which showed that we have passed the 3 minutes barrier, and that is what we call the transition into the irreversible sequence. That sequence basically means that now we're committed to launch because the automated sequence that has been started about half an hour ago has now triggered activities on board of the launcher that cannot easily be redone. So, for example, it's the pressurization of the fuel tanks, it's the opening of the fuel tanks at some point, and that is the point when you basically, when you can't actually turn back and when you need to launch.
So only 2 minutes to go, and the final sequence is just starting. But are we going to hear this countdown in Russian, do you think?
I'm afraid that we only see the pictures. I hope we see a countdown somewhere from the control room. But I think there's an important point to mention. We saw the countdown, and if I'm not mistaken, the countdown is actually counting down to a reference time that we called end of gyro setting time. That is not the actual liftoff time. So you need to be prepared that another 14 seconds, nothing is happening. Well, after 11 seconds, you will see the ignition of the engine. That is absolutely normal.
We must go over to there now, actually. So let's watch and listen to the launch of ESA's Sentinel 3A from the Plesetsk Cosmodrome, and we will talk to you again after the liftoff. Ladies and gentlemen, Sentinel 3A has lifted off into space, and I'm sure you'll agree that was a very impressive flight. Now, of course, we're entering into an exciting early phase of the flight, which is going to be shown here on our screens. And we're going to be starting to see some of the telemetry come through. So do you want to talk us through what we're seeing here, Matthias?
Yeah, we have seen the liftoff and basically the quick disappearance of the launcher into the night sky, which is related to this, very high thrust power that the rocket has. It has twice the thrust to lift, twice the thrust that is needed to actually lift the rocket. And now we see here already the first flight takes about 2 minutes, and the first stage flight takes about 2 minutes, and then the first stage separation takes place. So that is actually what we see in this animation, and what we see as well is basically all the maneuvers that the rocket is performing during ascent in an animated version.
Okay, and so of course we are now 3 minutes into the flight of the rocket. How does the data of its position come down from the rocket to us here?
We are actually using telemetry that is downlinked from the launcher to Russian ground stations. Just a remark, that is the indication that at that time we're expecting payload fairing jettisoning. That is taking place at about 120 kilometers of altitude once we have left the atmosphere. So coming back to your earlier question, the telemetry is basically downlinked to Russian ground stations that are located on Russian territory. That is also a reason why we're later on losing visibility. That is absolutely normal, and that only indicates that we are going into a flight path that is on the other side of the world, seen from the Russian territory, so that we don't have telemetry only shortly before we have separation.
Now we're seeing all of the different stages coming off there. Can you tell us why it doesn't all happen in one go? Why does it happen in stages like we've seen?
Well, that is a way to optimize the efficiency of a rocket. So a rocket mainly consists of fuel that is needed to accelerate the payload, and you need a bit of a structure to put fuel into, and you need an engine. But once you actually have burn down all the fuel, then you can get rid of the heavy structure, and you go over to a smaller rocket which is then fired again. So at this point we are flying the second stage, which will be fired for about 3 minutes, and then it will be separated as well, and then only the breeze upper stage is continuing the flight and is putting the spacecraft into orbit.
So what happens when the breeze upper stage comes away? Can you talk us through that?
Well, it actually continues what the first two stages have done so far as well. It will enter into a 10 minutes acceleration phase as well. It will disappear into a zone where there's no visibility, so we will not receive telemetry at that point, but we will see the first part of that flight. And it will actually bring the spacecraft into orbital flight. That means it will accelerate the composite to such high speeds that it's not falling back to Earth again. I mean, the first two stages, they're good to accelerate a bit and to climb altitude-wise, but they all fall back on the Earth's surface, and that needs to be that's what the breeze upper stage is good for, to give the last push to space to bring the spacecraft into orbit. And
what are we seeing here with this graph before?
This graph that is on right now, and which is, that is basically showing the flight path, and it gives you an illustration. I'm not sure if you can see. You see these trajectories plotted on the world map. You see we're starting from Plesetsk, we're going north towards the pole. We travel above Greenland, and then we come down over the North American continent, Pacific, and about 1.5 hour, 1 hour, 20 minutes later, we will come up again over the equator, and that is the point where we'll expect a separation of the spacecraft.
Well, I've just heard as well that we're now in the first burn of the breeze, so that's good news. Everything seems on track, and we've entered into the cruising phase now. So at this point, I'd like to thank you very much for talking through everything with us, Matthias Muck. Thank you very much.